Hello everyone. In this example, we are asked to graph y equals 1/2 times cosine of the quantity 2x plus pi. It doesn't say to graph 1 period or 2 periods, so if that information isn't given, then we're just going to go ahead and be lazy and graph a single period of our function. All right, so if we want to graph a single period of our transformed cosine function, we're going to have to identify which transformations are occurring. And in this example, we have to be particularly careful because one thing we may not have noticed that is very crucial and important is the way the function was given to us, the inside of our function was not in that factored form. And so what would happen if we didn't notice that is we would misidentify the horizontal shift. The way it is written in this unfactored form, it appears like our horizontal shift is to the left pi units, but we're going to see here that is not actually the case. To correctly identify the horizontal shift, we have to factor the inside of our function. So whatever number is in front of x, divide that number out. So 2x divided by 2 is just x. Pi divided by 2 is pi over 2. So now we have our function, or the inside of our function, written in that required factored form. Now we can see our horizontal shift is actually to the left pi over 2 units instead of pi units. It's easy to make a mistake when kind of factoring the inside of your trig function here. The way you can always double check it is redistribute that factor back inside of your parentheses, and you should get back to where you started. 2 times x gives me 2x. 2 times pi over 2 gets us back to pi. So now we can easily identify the 3 transformations that are occurring to our cosine function to get us this new version of our cosine function. The factor of 1/2 out front is going to be a vertical compression. So we'll have to multiply all of our y values by 1/2. What about that factor inside, that factor of 2? Well, that is going to be a horizontal compression. Remember, our horizontal stretch or compression factors are always the reciprocal of our b value. So we're actually horizontally compressing by a factor of 1/2. Let me loop that over here. And then now we can identify the true shift. It's going to be a shift to the left, pi over 2 units. Factored the inside of our function, identified all of our transformations. The next part is to transform those 5 key points that make up 1 period of our cosine function. All right, so eventually we'll probably graph enough of these examples to where we just memorize those 5 key points on our sine and cosine function. But if we ever forget, we can always go back to the unit circle and help get those points from there. So the first point on our original cosine graph is 0, 1. Our next point is pi over 2, 0. Then we have pi negative 1, followed by 3 pi over 2, 0. Then we're essentially back at the start. Once we've hit that point, 2 pi, 0. So now we have to be careful and do our transformations in the correct order. We can do our vertical stretches, compressions, and flips if we have any at once. And then we follow all that up with our shifts. So we can do our vertical compression by a factor of 1/2, as well as our horizontal compression by a factor of 1/2. So this next column in our table is actually going to be taking these original 5 points and transforming them to find the corresponding 5 points on this intermediate function, 1/2 cosine of 2x. So we divide all the x values by 2, so that'll become 0, pi over 4, pi over 2, 3 pi over 4, and pi. That takes care of our horizontal compression by a factor of 1/2. We also have to take into account the vertical compression by a factor of 1/2. And that'll just have us multiplying all of our y values by 1/2. So we get 1/2, 0, negative 1/2, 0, and 1/2. Looks like I caught a little typo or mistake over here. That first point should have been 2 pi 1. All right, so we've taken care of that first set of transformations. Now we just have our shifts left over. And our shift is to the left pi over 2 units. And so now we are going to be looking at points on the graph of the function we're actually interested in, 1/2 cosine of 2x plus pi, or 2 times the quantity x plus pi over 2. Doesn't really matter if we write it in that factored form at this point or not. The whole point of writing it in that factored form is just to initially identify the true horizontal shift, which we have now done. So to introduce this shift, we have to subtract all of our x coordinates by pi over 2. I'm going to have to do a little scratch work to get that done. But assuming I didn't make any arithmetics here, our new x values should be negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2 respectively. And no changes occurring to our y coordinates through this horizontal shift, so they will remain the same. I just have to make sure I don't make a mistake when copying them back down. It looks like I managed to do that. All right, so now we have the 5 key points we need to graph one period of the function we're interested in, this transformed cosine function. All right, so let's go ahead and prep our axes. And so we can see that our axes are going to have to go from negative pi over 2 up to positive pi over 2, and they're in multiples of pi over 4. And let's see our y-axis. Let's just say that's 1/2 here, and then negative 1/2 will be right about there. Not too worried about the actual scale between our two axes. Let's go ahead and plot our points now. So our first point is negative pi over 2, negative 1/2. Then we're at negative pi over 4, 0, followed by 0, negative 1/2, pi over 4, 0, and pi over 2, 1/2. So it looks like I made a mistake in plotting that first point, but I was able to catch it before it was a little bit too late. That first point should have been at negative pi over 2, positive 1/2 instead. So now we have our 5 points here, and we have to remember to also connect these points with the correct sinusoidal shape or cosine curve shape. And so that's what our graph is going to look like. I always like to add a little bit more to the end behavior just to remind ourselves that this isn't going to keep going up. It's actually going to turn back around and start coming down. So here we have a rough sketch of one period of the graph of our function, 1/2 cosine of the quantity 2x plus pi, or we could factor that inside as 2 times the quantity x plus pi over 2.